Good morning and good afternoon, and welcome to this conversation on MEC and edge computing. This is part of a report by Sensafili prepared in collaboration with RCR Wireless News. And today I have with me Lindsay Miller, VP of Marketing at Artisan. Lindsay, thanks for being with us today.
Thank you for having me.
So, Lindsay, with edge computing, mobile operators and other service providers are looking at ways to improve performance and quality of experience for their subscribers by moving functionality to the edge. And you've been doing a lot of work on this area for quite a long time. Can you tell us what is that how you got into this and what you've been doing so far?
Sure. So Artisan has been part of the wireless infrastructure for quite some time. Historically, we have been providing embedded computing and power conversion products to telecom equipment manufacturers and service providers. And our platform started to trend toward technologies that really needed to do more at the edge, more locally, more real-time functions. And so we got involved in a very dense compute platform we call MaxCore, which lends itself really well to mobile edge computing, deploying multiple different virtual network functions, and putting in a lot of processing power in a small space. And we've always been doing that in one way or another at Artisan, from platforms down to blades, from our Emerson Network Power and Motorola lineage. We've always been involved in serving the wireless infrastructure. So this is an area that we're really excited about and honored to contribute to.
Right. So you started before MEC even existed. And so you had the basis covered when it comes to mobile edge computing. Is there anything different that you're starting to do with mobile edge computing?
Yes, definitely. I mean, before a lot of functions could exist, but in, let's say, a slower, more disconnected fashion. So you had to rely upon the core infrastructure to do a lot of the compute resource that we enable instead of provisioning that at the edge. So you inherently had a network that was not really provisioned as efficiently as it could have been, which is one of the biggest merits of ENF, or of network function virtualization. And you also just couldn't do a lot of the services that you now can by having that capability at the edge, at the location where the user wants to use it.
Yes, and I guess that allows operators to allocate the resources as they need it, depending on the location, not just provisioning from the core.
Right, which gets us excited because it means that we could potentially save them a lot of money. And so if you're provisioning for peak capacity, then you're putting a lot of equipment in a location that may not need it all the time. An example would be a shopping mall or a sporting event, a concert. May be completely full of users one minute, maybe completely empty the next. So we can now, with mobile edge computing, provision a network based on moving to where the population is going, and maybe even changing the functions within it based on the services that they want to use while they're there.
And you're right, because if you imagine, say, a mall and a stadium, you might have, not the same number of people. You might still have a high density of subscribers, but what they want to do is different. So if you're in a stadium, they probably want to do a lot of video and video uploads. And those are really challenging from an infrastructure point of view. So how do you deal with that?
Well, we're focused on a couple of things. We're focused on density and latency. At the end of the day, we are the hardware provider. And with mobile edge computing, the promise is that you can do so much more at the edge with all these unique and innovative applications, but on general purpose hardware. So we're basically taking that hardware and making it serve more users in as much, with as many services as possible in one place, depending upon where they go. So within our platform, we are focused on reducing latency. So the communications and the compute functions that are within that platform, enabling all those functions, are happening as quickly as possible. And that could be the difference from seeing a live video streamed from a drone versus sitting there and waiting for your Instagram picture or video to upload or download from the network. So that's latency. And then the other thing is really just density. We're trying to get as many users and as many cells in a small space based off one edge platform.
Yeah, and I guess stadiums are it's a perfect example where you have both density and latency requirements at the same time. Can you tell us about some of the trials you've done on this in this area?
Yeah, I think this started for us officially in 2015 at Mobile World Congress. We were excited to partner with China Mobile, who was one of the first ones to be as outspoken as possible about mobile edge computing and virtual RAN, along with Wind River and Intel. And that year we also did a demonstration with Telefonica and SK Telecom. Since then, we've been involved in various different demos, China Unicom, Bicells, we did a drone demo. We've also been involved with Deutsche Telekom at the NGMN conference. NGMN has actually been the source of a lot of great info on mobile edge computing and 5G. So we're excited to be part of a lot of different initiatives with operators, because many of them are being really innovative about this and really getting very hands-on about how they can take advantage of this, because it means new services to them. Another one is Verizon. Verizon recently did a innovation lab challenge where they invited multiple technology providers to come in and show some new services. And one of the categories for that competition was low latency, and we won the low latency award with our MaxCore platform because we were essentially showing a mobile edge computing application. We were showing 360-degree virtual reality in the context of a sporting event. So imagine you're at a stadium, you're watching a game live, something just happened, you want to see a replay. You could actually hold your phone up and see a replay of that 360-degree view. And so that's what we were showing based on our platform. And we think that that is a great example of new services that operators can deploy that users will just come to love and not figure out how to live without.
Absolutely, and yeah, we have a lot of examples where once you start to add the service, people really start buying into them, even though you were not planning it ahead of time. So can you tell us, so this is a very good example of a new service. Is there other new services that operators are looking into that is more than just streaming up or down?
Yeah, definitely. When you look at some of the virtual functions that mobile edge computing can put in place, it's exciting from a consumer point of view as well as enterprise. So if you think about things you can do with enterprise, we actually partnered with one of our application partners, Clavister, to show virtual security gateways. So based off the same platform, we can show over 3,700 virtual security gateways being enabled by that platform. I recently attended the Mobile Edge Computing Conference, and we saw Carnegie Mellon show one of their examples, which was a virtual network function based on facial recognition. And that's really exciting when you think about how a location-aware element like that can identify users and know them and cater things to their needs. So we've talked about virtual reality, but augmented reality, ad services, ad monetization, those are all great directions that you can go as far as ways that operators can enhance the user experience based on mobile edge computing. The drone demo is another one that we did, and so you can imagine how video footage from a drone is a great application at live events that can be powered by the mobile edge computing network as well. So a lot of different examples there of things that we've been involved in. Really, the focus is on which of these services can help operators, make money now. And those are the ones where we have the most keen interest from customers and operators on how can we provision the service. And so those are the areas that we're focused on right now, even though there's a lot of exciting ones for the future. And for 5G, we're really focused on the ones that can help them take advantage of their networks now.
Yeah, and I guess that knowing the location and being able to have local services, it's very important, especially for monetization. So for instance, advertisements or applications where you deliver content that's really tied to the location, right?
Yeah, I mean, even concessions, it could be something that simple. But if you think about Pokemon Go as an example of augmented reality and how you can enhance a user experience while they're shopping, maybe seeing a game or something like that, you could make it really fun, and you could make it something that users really want to buy into and want to use while they're there.
Right. Now, MEC and NFV are being connected at the same time. How is that changing your position, Artisan's position within the value chain, or is it changing at all?
It is changing our position in the ecosystem a little bit, but it also gives us another opportunity to show how our platforms can really help drive that forward. So when you think about NFV, you think about a couple things. You think about dynamic provisioning and how you could do that better as a general application of that theory. But in another way, you can think about the exciting possibility to enable multiple different virtual network functions on one platform. So before you had multiple different bespoke appliances that all did different things, now you can bring those into blades in a platform and they can be doing different things, and you can turn them on and you can turn them off. So network slicing is essentially, the amalgamation of all those different virtual network functions, and we think a lot easier for operators to deploy, because now they can go and say, I want to pick my very best application solution providers. And then I want to have this general purpose hardware that I know is going to be high performance. I know it's going to have low latency. I know it's going to have high density. So I can do lots of different applications, and I can also do them quickly. I know if there's a real-time one I want to incorporate, this one is going to work for me. So we're trying to build that rock solid platform that can go in all of those different directions, and then work with the various different application solution providers to benchmark and show how it's real. As a company, traditionally, we have sold to the telecom equipment manufacturers, the appliance vendors, but because of NFV, our role changes. We actually go into a position where sometimes we sell directly to the service provider, but we also are working together with that telecom equipment manufacturer to make sure their application software is running on our platform in the best possible way. So we're open to both models, because ultimately those telecom equipment manufacturers could be the super integrator of all those different things. And in some cases, they may just empower the software that runs on our platform. Either way, we're open to that. But our differentiator and what makes Artisan unique in the market is that we are an integrator for complex workloads. So whether it's a real-time function or a mix of different types of resources, different types of compute resources, could be Intel, could be NVIDIA, could be FPGAs, could be camera inputs. We bring all of those things together in one platform that can go in all those different functions.
So I guess that this means that you might want to or have to work more closely with operators, because operators take a more active role in deciding what is in their network, the core components in their network, right?
Right. And we're excited to work with some of the ones that are really innovative, because they know which ones are going to help them monetize those services. And they have very specific problems to solve. And I think that our team acts as a good extension of their resources when it comes to that. And so we've been really thrilled to collaborate with so many of them already on mobile edge computing.
And now, sort of going back to virtualization and NFV, it seems like NFV is the sort of the foundation. So you need to have NFV for MEC to happen. Is that right, or is it somewhat separate?
I mean, I think it does kind of go hand in hand. I mean, if you think about the way that some of these problem areas that are great candidates for mobile edge computing, the way they're deployed today, it's like in the enterprise context, or at a stadium, it could be a lot of DAS equipment that the operator, it's not really their problem right now. It's owned by the building owner or the stadium provider, and then they can't go and offer great services on that network because it just doesn't really scale. So I think that mobile edge computing really does need NFV. You need to have equipment that is dynamic and can expand and contract based on what the network needs. And I think there's going to be a big sea change here on ownership of the network as a result of mobile edge computing. Because if the stadium owner can take that overhead off their plate and not have to buy and maintain that equipment, but can instead buy it as a service from the operator, and the operator can ensure that that network is going to serve up those ads and going to provide that content that they want to stream to their consumers, then it's really kind of best of both worlds, I think, for both sides of that equation, because the operator can actually now monetize services that they couldn't before, and then the stadium owner no longer has to maintain something which really isn't their core competency anyway, and is frustrating to the people that come to their venue today, quite frankly.
Right. Yeah. No. Absolutely. And also the stadium owner can basically support. I mean, provide the same infrastructure for different operators. So there is some consolidation at the edge.
Yeah, that's really exciting. Having an operator agnostic sort of framework there.
But and that also might be very important or crucial for the business case, because with MEC, you're basically adding infrastructure to the network. And so there is a question as to how can you justify the business case? You have an improvement in performance, but is that sufficient to justify the cost? So maybe there is a situation in which the venue owners can contribute to the initial cost.
I would think so, because there are areas where they can benefit from that being in place. They can, imagine if you're at a sporting event and the venue owner can serve up not just concession ads, but, like here, jerseys or things you would buy in the store that you otherwise might not physically see as you're walking out, but it comes up on your app. And you can have it shipped to your house. I mean, all sorts of interesting follow-on purchases or loyalty could happen as a result of that experience.
Yeah, absolutely. Now, we were talking before a little bit about 4G and 5G, and there is some view that you need to have MEC for 5G, but you don't have to wait for 5G, or will we have MEC only when we have 5G? What's your view?
Well, I would say certainly not. I think you don't have to wait for 5G to take advantage of MEC. I mean, it's here now. Couple examples. We demonstrated 96 cells on our current platforms, and that was LTE with Intel. We also partnered with another company called Amerisoft, and we're getting up to 120 cells, and that's 2x2 FDD LTE. So we know that with LTE operators, they're kind of in this lull because they expanded their network, they made it better. Equipment providers had a nice boon from that build out, and then things sort of kind of leveled off. The thing is, though, the LTE network it has so much capacity still, and some of these services, video, etc., you can do now on an LTE network. There are many new services that can be deployed on an LTE network without having to rip and replace. So I think there's a keen interest from operators to go and take advantage of that infrastructure that is there and build on it. And I think MEC is a wonderful bridge between the LTE network that is there today and the 5G ready network that will come in the future, but we don't have to wait for 5G.
What will 5G, how will 5G make it MEC better and more powerful?
I think with 5G, it's going to get really exciting in the context of what the users can do. I think when you think driverless cars, machines that can communicate with each other, that's where 5G is going to bring a completely different level of performance that just based on how much more bandwidth 5G is going to allocate in its spectrum for applications like that, more real-time applications, and let's say more mission-critical applications. I think with LTE, we're not going to have as many services that are life or death. They might be really exciting and cool and fun from a consumer point of view, but when you talk about actually handing over a lot of that control into functions that you never dreamed of before, without human interaction, that's where 5G is really going to be a different experience for all of us.
Now, in closing, can you tell us what is that you're currently working on? So we should expect from you at Artisan over the next, say, 5 years?
So kind of what you just asked me, our first stage for mobile edge computing was creating a platform and a technology that would enable you to do all these different virtual network functions and virtual RAN in the network, which is kind of basic tenets of mobile edge computing. Right now, we're working on taking that to the next level, to the mission critical functions. So we're putting more features into our platform that enable very high reliability. So looking at things that the telecom network has done historically at its core and implementing that at the edge, so you have high availability, high reliability. We're working on that, and we're also working on the incorporation of more and more processing elements that exist as types of resources within those platforms. So things like GPU functionality, very dense computing, higher connectivity, and proving out all those different applications with our different ecosystem partners. So it's a lot of work, but it's exciting. And when you look at the operators that are moving fast in this space, they've got the use cases that will hit the market first. That's our priority. But in the background, we are an infrastructure provider and we integrate complex workloads. So we want to make sure that all these things are working together, whether they're doing graphics processing, compute, connectivity. That is essentially our core focus, and just making that better and better and more reliable at the edge is our design focus in the next couple of years ahead.
Lindsay, thanks for being with us today. And this was a conversation with Lindsay Miller at Artisan and about MEC and edge computing for a report by Sensa Fide and RCR Wireless. And thanks all for listening in.